All right, so today we're going to look at what are called geometric sequences. So these are sequences where you're not looking for a common difference. What we're looking for here is a common ratio. Now that sounds a little funny because ratio generally means you're dividing by something, but a common ratio in this instance means that the next number in the sequence is found by multiplying by the same factor. And you may or may not remember that a factor simply means a multiplier. So anytime you're talking about factors, you're talking about multiplying. Things that are multiplied are called factors. Okay? So you might get a sequence where it's like 2, 4, 8, right? You're multiplying by 2 every time and it goes up. They can get smaller. The factor can be below 1. In other words, a fraction or a decimal, in which case you would actually be dividing and not multiplying, right? Because when you multiply by a decimal, it makes the number smaller. So it looks as if you're dividing instead of multiplying. So you're going to have a common factor or multiplier. So we're going to look at how to recognize some of these. And if the first term is still a, then t to the n plus 1. Now remember what that t to the n plus 1 means. It means the next term, right? One bigger than the one you have before. The next term is always found by simply multiplying r times whatever term you're looking for. Right? So you're just multiplying the number with your starting point, okay? Now, they can go up or they can go down. So we can have geometric growth, okay? And that's where your r is bigger than 1. So you're multiplying, which is going to make things grow, make the numbers get bigger, right? So you're going to get geometric growth. You can also have geometric decay, and that's where your r is less than 1. So in other words, a fraction or a decimal, something smaller. So it doesn't mean negatives here, it just means some number smaller. It could be a negative though, however, but don't restrict yourself. If less than 1 doesn't just mean a negative, it could be 0.5, right? So something less than 1. If you have geometric growth, then you get a graph that looks like this. Can anybody remember what kind of graph looks like that? The graph of a what? An exponential. There you go. Is that you, Pat? Excellent. So, yeah. If it's negative, then you get the same graph, but sorry. That's totally incorrect. You get the same graph, but the numbers are getting smaller as you go to the right. And eventually it looks like they get flat, but they don't. They get closer and closer and closer to the same value, but they never start. This is called the exponential curve. It can go up or it can go flat. Either way. Okay? So you can either start out with a big number, then continue to get smaller, or they can start with a smaller number and then continue to get bigger. It looks like half of a parabola, half of the graph of a quadratic. Okay? So we're going to look at some of these sequences and just determine what the common ratio is, and then find the nth term by just using recursion. Recursion just means you're just doing the operation, the multiplication. Then we're going to look at graphs and see if we're dealing with geometric growth or geometric decay. So that's why I was pretty comfortable putting this one in before you go, because it's really a fairly simple idea because we've looked at so many with the arithmetic sequences.